So I am going to introduce our speakers to you. So first of all, my name is Helen Gavin, and I would describe myself as a sustainability professional. I'm based in the Environmental Change Institute, and I have lots of expertise of water and energy issues, and I am the host today. Now, first of all, we'll hear from Esther Dudek. So Esther is a senior consultant at the power engineering consultancy EA Technology, and she has nearly a decade of experience working on projects on how to integrate low carbon technologies into distribution networks. And between 2016 and 2019, she was the technical lead for Electric Nation, which is what she'll be talking about today. And she was responsible for analysing data, reporting back on the findings within the project, and which was all about using smart charging systems to manage the additional electricity load on the local network from electric vehicles. And then we'll hear about a different project from Priya Bhagavathy. Priya is a postdoc research associate at the Energy and Power Group at the University of Oxford, and has an undergraduate degree in electrical engineering, masters in energy systems, and a PhD that looked at barriers and solutions for PV in the UK. And Priya will be talking about an ongoing project she's involved in called Park and Charge. Oops. Which focuses on that dilemma of how to broaden access to electric vehicles to people who don't have space to charge them off the road by their home. Okay, so with that introduction, I'm going to hand over now to Esther. So Esther, please can you take the floor?
So I'm going to start off giving a kind of background to electrification of transport in general, and then I'll move on to talk about Electric Nation in more detail. So my aim in this 10 minutes is to really explain what the project was, what we did, and 3 of the key findings. I guess it's worth saying that this was a 2-year project. We had a lot of data. I can really only scratch the surface in 10 minutes. So at the end of my presentation, there's a set of links for where you can find out more. We know that EVs are becoming increasingly popular. We could see that in the poll results in terms of the number of people who were interested in getting an EV or perhaps already did have one. And that's coming partly from a desire to reduce carbon dioxide emissions and also improvements in local air quality. And I've got 3 graphs and a statistic to kind of illustrate the trajectory that we're on. So the first is showing what's happened in the last 9 years. So this is the growth in the total number of plug-in vehicles in the UK car fleet each year. Now, you can see that's growing and growing quite quickly. Overall, there's still a small proportion of the fleet and a small proportion of new car sales, but it's growing, and it was the only type of vehicle where the sales really stood up to all the other declines that we saw in petrol and diesel cars through lockdown. My second graph gives an indication of where we're heading in the relatively short term. So this is about how many models of plug-in vehicles manufacturers in Europe are planning to make available out to 2025. Again, you can see that increase from lots more manufacturers, and this is partly driven by an EU target that comes into force this year. My final graph takes a much more long-term view. So this is from National Grid's Future Energy Scenarios work and was published last year. And you can see the demand for petrol and diesel in the yellow dropping off and declining very sharply to almost nil by 2050, whereas demand for electricity in the purple increases. The EV Energy Task Force have also looked at this as an issue, and they've estimated that in order to meet the aims of the government's Road to Zero strategy, electricity consumption would need to increase by about 30% by 2050. So it was really against this background that Electric Nation was conceived. The electricity industry has been working for some time to understand the extra demand that EVs will place on networks and how this can be managed. So the element of the trial that I'm going to talk, element of the project that I want to talk about today is the field trial, and the aims of that boil down to what's on the slide. So really understanding the impact that charging EVs at home will have on distribution networks, and whether this could be managed by smart charging. It was a Western Power distribution project which ran between 2016 and 2019, and it was delivered by the project partners that are on my slide. EA Technology, the company that I work for, and Drive Electric were responsible for the field trial. Might be worth highlighting here that one of the requirements of taking part in Electric Nation was that our participants had off-road parking. They had a driveway, and we could put the charger on the side of the house or in the garage. So it's looking at a different segment of people to the issue that Priya is going to address in her presentation later on. This slide kind of summarises who was involved in the project, what sort of vehicles. So we had 673 participants, and we didn't place any restriction on them in terms of what type of plug-in vehicle they had. So you can see on the pie chart, we had a breakdown between people with full battery electric vehicles, plug-in hybrids, and also some range extenders, which is the BMW i3. And the battery sizes were spread out from everything from a 4.5 kilowatt hour Toyota plug-in Prius to 100 kilowatt hour Teslas. And because we had this breakdown and because we had so much data, the over 130,000 charging events, we could actually break down things like charging behaviour and attitudes to smart charging by what type of vehicle people had. We had 2 providers of smart charging. They each did 3 iterations of their system, so 6 different systems run through in the project. When I talk about smart charging in this project, what I mean is controlling the charge rate by sending a signal from the charge point management company to the chargers themselves. And in this case, we did that based on available network capacity. And the graph is illustrating what we might be trying to do there. So the pink would be underlying demand in winter. You can see if you add EV charging demand onto the top of this, you get the blue curve. And we have this period over the evening peak where that demand exceeds the network capacity. One option would be to reinforce the network. It's very disruptive, it's costly, there's a lead time involved in that, and also quite inefficient because you're talking about building more capacity for that very small period in the evening where actually there is capacity later in the evening and overnight. So if we could just move that additional demand, you could avoid that reinforcement. I'll move on to talk about the key findings from the project. So the first one was about flexibility. So we compared how long people left their car plugged in for how long they were actually drawing power. So if you imagine a situation where you get home, you plug your car in, and it's only plugged in for 2 hours, and it's charging for the whole of that 2 hours, then really if we slow your charging rate down, when you come to unplug your car, it's not going to be as fully charged as you expected. So in that scenario, there isn't flexibility. If, however, you get home in the evening, you plug your car in, and it's going to stay plugged in until 8 o'clock the next morning, and it only needs to charge for 2 hours, then we could slow that charging down and actually not impact your state of charge when you unplugged at all. And that's what we were looking at with this flexibility metric. And the good news is that, yes, it varies through depending on what time you plug in, but for people who plug in the evening peak, which is when we might need to do some management, you can see there's a really high level of flexibility in there. But we did also find that without any form of management, this additional demand that would be placed on networks would exceed network capacity in some cases and in some seasons, so particularly winter weekdays, which means there's a need for management or some other sort of incentives to avoid creating this additional peak demand. So we did demand management in the trial, and we proved that this was technically feasible. So we had some issues with communication technologies, which is sort of par for the course on this type of innovation project, but overall the system worked well. And alongside collecting the data about from chargers around sort of specific charge events, we also did a lot of surveys. So we could understand from our trial participants how satisfied they were with their charging arrangements. And those numbers remained high throughout the whole trial. So before they were managed and while they were being managed. And the other thing that we found out is that there is no correlation between how often people were managed and how satisfied they were, which means that people who were never managed were as likely to be highly satisfied as people who were managed very regularly, which is a good sign because that suggests that management doesn't make people dissatisfied. In the later parts of the trial, we introduced apps to the participants so they could use that to influence how likely it is that they would be managed. And some participants used those. They valued the option, that being there as security, but they didn't use them very regularly. The level of overrides was very low. Time of use tariffs are one of the options that are available to incentivise drivers to charge outside of peak times. We trialled an incentive system with our participants and provided them with an app so they could easily use their smart charger to ensure they only charge at the cheapest time. And the change in the load curve when we did that was dramatic. So you can see on the grey curve, that was the demand that we had in the first winter trial. So in that case, the peak during sort of tea time period, 6 o'clock, 7 o'clock, was lowered because we were managing people. But you can see it's still there. And it's slightly later in the evening because of that management. Compare that to the blue curve, which is what happened when we had our time of use system in place, and you can see the large reduction in load over the traditional evening peak. You're also probably looking at that graph and going, well, what happened at 10 o'clock at night? The answer is all the charge events that would have happened through the evening peak all started at 10 o'clock, which was kind of a function of the way that trial system was designed. In reality, you would have put some randomization in there in a business as usual situation, so you wouldn't get that big spike at 10. We also found that by giving participants an app, they really valued the way that made it easy for them to interact with the system and maximize their reward value. So most of the participants used the app at least once. Nearly half of the charge events were done on a setting that meant that they would avoid charging in peak time, and the participants were really positive about using that app and the trial 3 experience in general. So you can see the statistics in the speech bubble on the slide. You might have seen some of the coverage that's just gone out around a sort of follow-on vehicle-to-grid project from Electric Nation. This is being run by CrowdCharge and Drive Electric and is about looking at how much additional benefit you can get from vehicle-to-grid, and particularly when you offer that alongside energy management companies. And we'll be involved with looking at the network benefits of doing that later in the project. My final slide gives you some links to where you can get more information on the project. So we have a 32-page summary document, which will give you a really good overview of the project and some of the findings, and also the full technical report, which has got a lot more of the details, particularly around charging behaviour and customer surveys. And if you've got questions, then feel free to email me.
Quick question, webinar to you, Esther. How did participants in your trial attract this reward system, given that they would have been on a tariff? We have a standard tariff. There's only one tariff in the UK that has a variable rate. So could you just explain that a bit, please? Yeah, sure. So as you say, this was the purposes of trial, so we weren't going to be asking our participants to sign up for a different deal with a particular energy supplier. What we did was monitored the energy just going through their EV charge point, and then did a reward system based on when they used that energy. So it was a tariff set up with high prices during the evening peak, and if they charged then, it would reduce this reward value they were racking up. If they charged pretty much anywhere apart from the 3-hour window at the evening peak, their reward value went up. And whatever reward value they'd got by the end of the trial just before Christmas, we converted into an Amazon voucher and sent them that. So I think on average people got about £20. We had some people who got all the way up to sort of £80, £90, and most people managed to increase their reward value a little bit. Okay, thank you. Well, there's some good questions for you in the chat pane, but what we're going to do is just wait for to the end. So we're going to hear from Priya next, and then we're going to have a full Q&A session afterwards. But thank you very much, Esther. You might want to just look through the chat pane to see all the questions in there that I'm going to be asking you later. If you can stop sharing your screen now, that would be excellent. And we can now hear from Priya.
Yeah, thank you. Thanks, Helen, for the introduction, and thanks, Esther, for the lovely presentation. I'm Sivapriya Bhagavathy. I'm a researcher at the University of Oxford. My core area of research is decarbonization of the electricity sector. So my work includes linking energy technology to the energy policy, as well as looking at multi-vector decarbonization. So by multi-vector, I mean looking at heat, electricity, and transport together rather than individually. The key project that I'm currently working in is the Park and Charge, about which I'll talk about in detail. And this work is actually complementary to what Esther discussed so far. So Esther said about how smart charging and vehicle to grid can be used to support the national grid if people charge at home. But the question still remains as to how do we people who don't have an off-road parking or an off-street parking get access to the charging facility. So before we go on to the project or the details of the project, I want to introduce the consortium. The consortium includes Zeta, who is the manufacturer of the EV chargers, and UI UK, who is the technology partners or who integrates the data from the chargers and also acts as the charge point operator. The SSE, who is the infrastructure provider for this project, and the Oxfordshire County Council acts as a unifying authority for all the 5 district councils. So rather than going to individual district councils in the Oxfordshire, we directly deal with one entity, which is the Oxfordshire County Council. And finally, we have the University of Oxford, which includes me as well as people from the Transport Studies Unit. We are providing the expertise on the technology as well as the data analytics aspect. And some part from the TSU will also be dealing with the social sciences aspect. Let's look at what is the status of EV. We saw how the EV was growing. So this graph shows the regional distribution here. So the figure on the left shows the current sale of battery electric vehicles as a percentage of new vehicle sales. So you can see clearly that Southeast England and London has got a very high percentage. So it's up to 30% of new vehicle sales in the quarter from Jan to March 2020 was electric vehicles, which is a good progress compared to the rest of the nation. And if we look at the figure on the right, it shows the number of charging points or the public charging points per 10 battery electric vehicles. So according to the European Union guidelines, maybe Brexit will have an impact on that guidelines, but they recommend that we need at least 1 public charger per 10 electric vehicles in order to facilitate a faster uptake of the electric vehicles. So even though we have a high percentage of electric vehicle sales happening, the number of public chargers is only 1 per 10 electric vehicles, which means that we also need more as we move along the line. So looking ahead at what are the challenges if we want more people to buy these electric vehicles is that there is a lack of chargers. We just saw in the figure that we only have 1 per 10, which is not good enough. And 30% of the households in the UK currently do not have access to off-street parking. So even if I do have an off-street parking, it doesn't mean that I will be able to put a charger in my place. There are more than 50%, or there is a considerable amount of population who are living on rented properties, which means that even if they have an off-street parking, they cannot install a charger, or they are in apartment blocks or communal areas where they do not have the rights or the legal rights to put the chargers. So how do these people if they want to buy an electric vehicle, get one and get access to the chargers? We can have 2 options. One is on-street charging, but the installation of on-street chargers creates local disruption during the installation. It adds to the general clutter on the street with excessive street furniture and congestion. It also leads to conflicts with other car owners. For example, if you have a lane where there is a huge amount of on-street parking, you mark a bay as purely for electric vehicles. And if there are no electric vehicles bought in that lane, then it leads to a conflict as to, oh, there is a bay that is being not utilized. Or if there are 2 cars, then again, whoever comes first will get it and the other person will always have to wait. And that leads to further conflict. And we have had examples of having to call 999 just because there was a fight between 2 vehicle owners. So that is an experience from another project. But so on-street charging, though good, it's not an effective solution. So the approach that we propose is to utilize the car parks, which are near residential areas, to provide the charging facility. So if you look at the map here, the color of the roads are marked as red, amber, and green. So the color indicates the density of on-street parking. So if the road is red, it means that there is a heavy number of cars that are parked on road overnight. And you can see that there is a P. P indicates the parking spaces or the car parking spaces mostly owned by the councils. And you can see clearly that there, even though the road is red, there is a car park just next to it, which is not utilized at night. So an example of the car park usage in Bicester is shown in this graph. You can clearly see it's like from morning around 10 o'clock to evening 6, the park is utilized. Beyond that point, there is literally zero use of the car park. So you have a heavy on-street parking, but next to it, you have a car park which is not utilized at night. So there is an option, or there is a huge potential for space utilization in this context. So then in the feasibility study, we did a small survey among people in Oxfordshire to engage their willingness to walk. So the question was, how far from home will you walk to use a park and charge option? So about 1/3 of the population said they are happy to walk about 10 minutes, and about 2/3 were happy to walk about 5 minutes if they are guaranteed a parking place. So this shows that, okay, if the residential area is congested and there is a car park within 5 minutes of walking distance, that provides a huge potential to use. So going on to that, we then decided to develop a software tool which combines these two insights, that there is a GIS-based data that is available, which looks and tells us how dense the on-street car parking is. And also the radius of like 5 minutes is kind of the radius where people are willing to walk. So we developed a software tool, which is partly ready, but this is a project which we started last year in September, but due to the COVID, we have not been able to install any new chargers. So we are now looking at an installation sometime towards September to Jan next year. And once we have these chargers installed, the Oxford University researchers will look at the EV charging and their parking patterns, how the chargers and the parking bays are used. And also the software tool to identify suitable locations will be updated with the feedback that we receive from the usage. We also have the Transport Studies Unit researchers who will look at the users and non-users of these chargers to understand the whole system perspective, or like a whole neighborhood approach. They also conducted a survey to understand the parking behavior of the people. So we have the transport survey, which looks at how long the people travel, how often people travel, but there is not much surveys or not much understanding of how people park their vehicles. So this survey will help us with some insights on how people are currently parking their cars and how willing are they to walk, or how they gauge the distances. And that is, I'm hoping we will have some results out by end of this year. And using the insights from the survey as well as from the actual charger usage, we intend to develop a software tool to site the suitable car parks. And last but not least, we have the intended output. The impact of COVID is not taken into consideration. What we intend to have is about 20 parks in Oxfordshire, which has about total of 150 chargers, combining 6 local authorities. And we are hoping that that will help promote more than 60,000 electric vehicles in Oxfordshire by 2030. The expected output is one business model, which shows how do we go about installing more of these chargers, which is a win-win for both the car park operator as well as the vehicle owner or a potential vehicle owner. One site location tool and one legal framework, and also a booking platform and a complete management system, so that you don't have to change from one subscriber to the other when you move from one charging location to the other. And that's it. Thank you.
I have a quick question for you, Priya, before we go to the main Q&A section, which is, how has coronavirus affected the plans for this? Can you just comment on that, please?
So, the coronavirus affected the legal framework we needed so that we can actually go ahead with the site inspection and site installation. So we had plans to, so the Oxfordshire County Council, which acts as a kind of common point for 5 district councils, they needed to meet or have an in-person meeting with the legal team of all 5 district councils to get the approval for the site inspection and to get an approval that these sites are good to go ahead for the next stage. So that was stuck in the system because the legal team were not happy using Zoom or any other online platforms to discuss, because legals being legals. And then they finally did it, and we have now got the confirmation that they're happy for us to go ahead. But then that meant a 3-month delay, and also Zeta, who is the EV charger manufacturer, they had to lay off 2 of their key researchers or key designers, which meant that their design process was delayed. So we had a knock-on effect of up to 6 months.
Wow, that's quite a lot. Thank you. Okay, if you could stop sharing your screen, that would be excellent, and we'll go to the main Q&A. So lots of questions coming in. So thank you everyone for putting in your comments into the chat pane. I'm just going to focus on those questions which relate directly to the presentations. So there's an early question from Roger. Thank you, Roger, who may have missed a slide of yours, Esther, and he's asking, are we expecting the total energy demand for transport to go down over time?
Yeah, I think that was what that's the graph for the future energy scenarios was total. I think it was total electricity use. I need to double check. There are lots of things that could play into that. I mean, not included in the 2019 scenarios was the idea that working from home is going to become a lot more prevalent, but also efficiency savings for vehicles. And also sort of trying to encourage people to switch to car sharing, public transport and things as well. I think just a one-for-one change of moving the total energy demand from petrol into electricity is not the most efficient way of doing this.
Okay. The question. Sorry, another question for you, Esther, about the app that was developed for the participants in your scheme. Were they allowed to express when they wanted their car? Was that one of the functions that then triggered what kind of timing the smart charging would operate at?
Interesting question, and one that I kind of couldn't elaborate on with 10 minutes. So I mentioned that we had 2 providers of demand management. So the simple app that you saw the screenshot of for the time of use tariff was from Greenflux. CrowdCharge took another tack where they did ask people for those kind of journey plans and to say, well, I want to leave the house at 8 o'clock tomorrow morning and I'm going 50 miles. And my state of charge when I plugged in was 30%, because you can't get that information automatically from the car very easily. What we found was that actually the level of interaction between users and an app that was much more sort of interaction heavy wasn't regular enough to get the information to do that kind of management, whereas actually the Greenflux's simple kind of override system that they did was enough. So I think it's one of those examples of keep it simple.
Okay. Okay, I'm just going to carry on with a thread of comments and questions for you, Esther. It's from Hindole. Thank you, Hindole. 2 questions. Number 1, there was a flexibility score on one of your slides, Esther. So could you just explain what the flexibility score was in the context of this project? And a second question, were the drivers asked to provide their minimum state of charge that was required?
Okay, so to take the second one first, no, they weren't. They weren't required to do that. CrowdCharge tried it. In terms of getting that information from the state of charge when they plugged in versus what they wanted for the next journey. But really that system was too complex because the communication protocol between car and charger is really pretty dumb. You don't get that information about what state of charge the car is actually at. So hopefully that covers the second question. The flexibility metric, at the risk of getting too maths heavy and giving you an equation. So if we take the time that you're charging and we divide that by the time that you're plugged in, and then we take that number away from 1. So if the time you're charging is equal to the time you've plugged in, then we get 1 minus 1, there is no flexibility. If you're charging for 1 hour, you're plugged in for 10 hours, we get 90% flexibility.
Okay. Okay, thank you. So question to both of you now generally about charging and the number of public chargers in different areas. So Priya, you showed those maps that showed the density of charges in across the UK. Just both of you commenting, what do you think is the reason for the unequal distribution of charges across the country? Priya, would you like to go first?
Well, I think it depended on where the investment went. The Northeast got a fair share of the investment in the first place because of the, I think it is because of the Nissan having their manufacturing plant there. And that resulted in a significant move. And that there was a significant assumption that there will be a significant uptake in the Northeast, but somehow Northeast didn't pick that fast. I don't have, and I think the other reason why London has a significant amount of EV infrastructure is because of the push to have zero emission zones. And as they made the zero emission zones larger, it made it mandatory to have, or a significant push to buy these electric vehicles. So I think it is a combination of the investment as well as the government or the local authorities' intention to go to these zero emission zones.
Yeah, so I'd agree with that. I think I hope we'll see a levelling out of that over the next 5 years as sort of public appetite for EVs increases. It's always a little bit chicken and egg as to, well, do you need to build the infrastructure first so that people can have confidence to buy vehicles? But we can see already that uptake is there, particularly where people have got off-street parking, and that I think will grow as we develop more infrastructure for those without that opportunity.
And is there there's an echo. Is there any trends that you've observed in any data that you've seen about charging? Are there some days or nights of the week that are more favoured for people to charge? Maybe people want to charge on Sunday night so they have a week's worth of travel in their battery, or have you not seen that type of trend?
So we did look at that in Electric Nation, and really what you can see the kind of obvious difference between what the demand looks like at the weekend versus weekday. Saturday versus Sunday isn't terribly different, and sort of good news really is that there is diversity in charging behaviour. So it's not the case that everybody plugs in on a Monday and then everybody plugs in on a Wednesday, because from a network point of view that would be worse because you'd be stacking up the peak demand. Whereas if you have some people who plug in Mondays and some do Tuesdays and some do Wednesdays, then you start getting the diversity that we get with other household loads, because not everybody does everything at exactly the same time.
Thank you for that. So Priya, I have some questions for you about the use of car parks for charging. One of the reasons explaining the lack of use of car parks at night may be because they're not open or because there's a fee. Will people with electric vehicles who will be parking there to charge, will they be charged for parking as well as for the charging?
So I think it is dependent on the car park. So I'll use the word build instead of charged so that I differentiate between the electric vehicle charging and the money that people have to pay. So some of the car parks are literally free for overnight parking, whereas some of the car parks in the city, especially in the Oxford city, are paid parking on an hourly basis. So it depends on where the car park is. So if the car park is outside the cities, then it is quite likely that there is no charge for overnight parking. Then the EV owner will not have to pay anything. Whereas if it is in the city, then they will have to pay something.
Okay, and can you comment on the willingness of electric vehicle owners to do this? So the question from Ibrahim, which is, what role has willingness to walk, to play in park and charge? So Priya, you showed a chart where most of your respondents wanted to park and charge 5 minutes walk or less. Can you comment on that, please?
So yes, so you can drive to the car park, but you have to walk back home. So that is a 5-minute walk about which we are talking about. The willingness to walk is very key in terms of walking back home. So it is not just the distance, it's also how safe they feel in walking back to their homes, how safe they feel in leaving it in the car park. So safety is also a very key ingredient to utilizing these car parks.
And are you anticipating on getting any data from people using this new car park system, or is it basically, it seems like maybe because of coronavirus delays, etc., you're at the point where the project will extend to the point of putting the infrastructure in, but how much time afterwards will you have for monitoring the use, maybe conducting surveys with participants?
We are hoping the whole project to extend by about 6 months, and even if we have like at least 2 or 3 car parks with this infrastructure in, we will be able to conduct surveys among the people who live near the car parks, so that we already were aware of this risk of not many people utilizing the car park. Because even though we have the infrastructure, it is like a chicken and egg. So you have the infrastructure, it is not necessary that people around that have car park have electric vehicles at the first place. So it is dependent on how quickly the uptake happens. But we, along with the transport studies unit, will use a whole neighborhood approach, where the interviews will be not just to the electric vehicle user, but also the other car owners, as well as the people who live nearby. So we get a whole perspective of the neighborhood rather than just the electric vehicle owner. So we still hope to get some feedback from the neighborhood.
Okay, so if one is an electric vehicle driver, one can go on something called ZapMap to see where all the chargers are and if they are actively being used at that precise moment. Will the system that you're describing, Priya, have that kind of functionality? If I'm an EV driver and I don't have a place to park off-road, will I be able to access some sort of live feed information? Or
yes,
will
so
they be put onto ZapMap?
You'll have live access to the charger, as well as a bookability feature. So you will be able to book a slot in that car park, and then you can go and arrive, be assured that there is a bay waiting for you, rather than, it may not be a designated bay, like it is not a numbered bay where you say number 3 is reserved for this electric vehicle, but no, there will be one bay waiting for you in the out of the 10 or 6 of the chargers there. So there is a bookability feature. There is also a subscription type of formulation, which we are looking at, where they will be able to do an unlimited number of times up to a limit, like the broadband, where you have, like, you can have 100 MB data for this much and about 200 MB or 2 gigabytes for some other limit. So we are looking at that aspect as well, so that the people can be sure of what is the money that is going to be involved in charging these vehicles. If it is a pay as you go, then there is a potential problem as to, okay, I am not very sure how much I will end up paying for this. Whereas if you have a fixed cost, then you know on your monthly planning that, okay, I need this much for my car.
And another question for you, Priya, but then I'm going to switch to Esther. But Jeff asks, would it be better to focus on putting chargers in supermarkets and sports centre car parks rather than general local authority ones?
Yes, it is a potential. So this first phase is with the local authorities, but once we have the business model up and running to show that it is actually a feasible option, then the charger owners and as well as the integration providers plan to take it to the private car park owners. Because right now, if you take it to the private owners, it is just a model. It is just something which looks promising, but they don't have any proof. So this study or this pilot demonstration helps them with a solid case study to look at these car parks and say, okay, yes, there has been a progress and there has been a continuous revenue coming up, and it is potentially something the private investors should look at. So that is the next phase. So that is there as a part of our exploitation plan.
Excellent. Okay, a question to you, Esther, from Matteo. Did you involve the owners of photovoltaic systems, and did you explore any potential conflict that they might have between self-consuming their own generated electricity to charging a vehicle?
So we did have some participants who also had PV generation. I can't remember the exact figure, but it is in the report. And we weren't, as part of the project, then sort of treating them as a specific group. We saw there wasn't a big, so we explored, for instance, do people with PV, are they more likely to charge during the day? And on the whole, we weren't seeing that, which I think is probably a function of the group of people who have PV and an EV, and how likely is it that they're going to be at home in the middle of the day. before lockdown and working from home and things. So on the whole, that kind of matching up demand for an EV and self-generation was more tricky in our project. That might change where you've got sort of home battery systems as well. Could introduce another dimension into it, but it's not something we looked at specifically in Electric Nation.
Thank you for that. I'm going to follow up with the question from James. Thanks, James. And he asked about the override function. Basically, to what extent is this override function plausible if we can put time of use tariffs into networks? Already we're seeing one electricity tariff in the UK which allows a time of use tariff. Sorry, this is aside from Economy 7. This is an active tariff from Octopus Energy that can actually go negative. So he's asking about that. He's explaining that, you know, lockdown has shown certain mob mentality. What happens if everyone just decides to basically override any time of use tariff and charge their EV at exactly the same time? Would the override function kind of allow that to happen because of the potential impact on the grid?
So the way that the override system was set for this trial, and I think the way that you would have to do this, ultimately, if the demand on the power network is too great and you end up in a position where that is potentially going to cause an outage, then it would be far better to reduce EV charging to keep the lights on at home and doing more sort of time critical things. So the way the override system worked in Electric Nation was effectively those who had requested an override got the highest priority. So current was allocated to them first, and then whatever was left over went to the people who hadn't pressed the button. Now, if only a few people press the button, that's fine, because you can give all the people who did capacity, and there's enough to do that. If everybody pressed the button, then you start managing them, because the network limit has the kind of top place in the hierarchy. Time of use tariffs and how that will affect things is an interesting one that we'll need to see as to how that develops, to what extent those become widespread, and how you integrate that with the sort of network demand signals. I know the Octopus Agile tariff, which is the one with the time varying things, that people with only cables have been essentially paid to charge their cars during lockdown because demand has been so low and generation quite high that there's been negative pricing. We actually used an hour's worth of Octopus Agile data to come up with our tariff for what our reward system looked like. So yeah, I can see there's an interesting conundrum there if a lot of people, as in a high proportion of the population, were on that same type of tariff. But I don't think we're there, or that we're going to be there for a while yet. Yeah.
Are either of you aware of any studies that have looked into the effect of different electricity pricing on electric vehicles charging? I guess it's a very new thing, and so if there are any studies being done, they will be in progress now trying to collect data.
Yeah, so the DNOs have done some projects looking at time of use tariff under their innovation mechanisms. In terms of looking at time of use tariffs and EVs, for things that are finished, Electric Nation is the biggest one that's there. There are various projects underway at the moment through the network innovation funding mechanisms.
Okay, thank you. Again, another question to both of you. A question from Troy asking if anyone has modelled the different future energy mixes and their availability to have an increased amount of EVs on the grid. Has anyone come out top? Now, I know that the National Grid Electricity System Operator pulls out its future energy scenarios every year, which explores these kind of things. Esther and Priya, would you like to comment on that?
It's an interesting one. My sort of personal opinion, looking at that question sort of straight at the bat, is that I think we probably need an energy system, and we design an energy system that it will meet the needs that people have. So the move towards electrification is key for decarbonisation, meeting net zero targets and so on, and the energy industry need to be able to support that. So whether we do that with a mix of a smart, what looks like the best option is a smart system with lots of renewables and some storage in there, and using electric vehicles as a flexible resource, potentially of the sort of size that we haven't had before, unless we start looking at large energy storage systems.
Yeah, oh, there's a good amount of echo, but I'll go on. So I agree with Esther in that the generation has to meet the demands of the people. It is not. It has been same so far, and I expect it to continue in the same way. But it is also important to know that these electric vehicles should have smart charging facility, irrespective of where they charge. And there is one study which a DPhil student in our group did in terms of understanding if the person just entered in terms of, okay, this is my percentage of charge at the moment and I leave at this point in the day, and then we can facilitate a smart charging, and the impact of such a charging would be very nominal on the grid, as against they just plugging in, and as soon as they plug in, if it is charged at full power, then that is going to have a significant impact. So that study uses the travel survey data to understand how what is the frequency of arrival of people back at their homes, and each half an hour is collated to do that analysis. So that's a good indication to say that if we are smart enough to use these electric vehicles or the charging smartly, then it is possible to meet the demands in future as well. And irrespective of what the demand is, we need a mix which is 100% renewable. So it is not going to be an option to say, oh, but just for the meeting the demand of electric vehicles, we will have a coal, or a coal is not at all an option, or maybe a gas plant just to support the peak. That is not going to be an option. That should already be taken off the mix. That's my personal opinion.
Yeah, I'd back up that point about the kind of need for smart charging and the impact that makes on the increase in peak demand. I think we saw that, can't remember, was the 2018 future energy scenarios, where there was sort of one scenario with smart charging and one scenario without, and the increase in peak demand for without was really quite extreme.
Okay, well, picking up on that, I'm going to ask the last question before we close, which was, it's come from Roger again, thank you, which is about, instead of using time of use tariffs which are based on a price, will there be eventually a move maybe to time of use based on carbon dioxide intensity or greenhouse gas emission intensity?
Yes, I think, and in some ways I think we're already there. So I know that the OMI system has a way, so it's a smart cable that can communicate with Optimus energy figures and then control what's happening with charging the vehicle. And I know that there are options in there around carbon intensity of generation. So I think that will be an option, and some people will make their decisions based on that. You might also see a strong correlation between what's happening with carbon intensity and also price, because if we think about the times recently where we've had negative pricing, that's been driven by low demand and lots of wind or lots of PV, because if you've got lots of renewable energy, you're probably looking at cheap energy as well, rather than burning things.
Priya, would you like to comment on that?
So I agree that it is a potential option, but then in future, when we have too much of renewables and there is less overall carbon intensity, then it becomes a different option altogether. So maybe for a transition, that might be an option, but on a longer term, it would be, it doesn't look like a feasible option for me.
Okay, thank you. I'm going to leave it there. I would like to thank everybody for attending this webinar. Thank you very much for giving your time. I hope what we discussed was of interest to you. I'd like to thank Esther and Priya as well. So let's all say thank you and goodbye by waving either our physical hands or our Zoom hands. Thank you very much.